Okay, so now we talk about multi-threading. Anyone have experience with you program any piece of software, piece of code that's running on like multi-threading before? Why do you want to do the multi-threading? Right, you want to utilize the resource from the CPU. So right now, you know the CPU are not single core; it's multiple cores. At least on the phone, two cores. Right. But if we run on the simulator, I don't know if on the simulator they limit that one in two cores to make it similar to the phones, or they still using 8 cores. On the map it will be 8 cores, and if we run on the simulator, I have never got a chance to figure it out on the simulator. How did they limit that one into 2 cores or still 8 cores? But if we run on the phones, it will be at least 2 cores, right? And then if we want, we have some tasks, some heavy tasks, and then we don't want to run on the main UI, right? Because that one it runs, it will be take a lot of resource. Either it take very long time to complete that task, or it will take a lot of CPU. So it's like cause your app like it lagging on your app, and then that's not something people want. For example, if you remember back to the first assignment when you do the loading the image, the poster from the internet. So that's one why we ask that to be done asynchronously. The image should be downloaded asynchronously, and then it will not block the main UI. So why the image is being downloaded? So you still can swipe up, swipe down. You see the text will be very fast, will be show up, but then the image will be later. Never mind. User can still like scroll up and down. As soon as the image will be downloaded, and it will be show up later. So that's one in those the case. So on the main UI, the thread on the main thread to update the UI is still responsive. Right? It's not like freeze your app. You still can swipe up, swipe down, and then the downloading code will be handled in another thread in the background. As soon as it finishes, that's when it refresh the image. Right? Okay, just a fun picture. In theory, so one task should be done on one thread, but then it's end up something like it's not easy to do the multi-threading. So it on the practical is something like this. Okay, so before we talk, we go to some code. So let's talk a little bit about GIOS. So actually, iOS is an event-driven system. So it has a run loop, and then the task in that loop is inside a queue. So it will continuously consume the event from that queue. So let's take a look on this one. This is, for example, you had some interact with the screen, and then this will go to the operating system. The OS will handle this one, and it put everything inside a queue. So inside this queue, so if we have a main run loop here, so it will iterate one by one in the queue, and then it can have some. It will handle those action here, and then it from the operating system it will update on the main UI. Right? For example, you want to zoom in something, or you want to rotate something. Every action will be going to this queue, and then whatever you do inside here one by one, then the OS will return the result and update the result on the screen back to the user. Right. So for the iOS, so iOS provides some option for backgrounding tasks. So when we say backgrounding, so some tasks either it's time consuming, it's taking like few seconds to complete, or sometimes that's taking a lot of resource. We want to put that one into the background. So we run the task in the background. We don't want to block the UI, the main UI. Right? Users still can respond on the users still can see the app is very responsive. It's not like free your app and then you have a big table view, you swipe up and it just stay there. And we also have the first one is the block and Grand Central Dispatch. So in short, is GCD. This is one of the things I able to drive for you. So we use this one to handle the multi-threading. Like put the code, put the block you want to run inside a multiple thread. So this one it will be like it handle the thread for you. You say hey, I want to run this code, this block of code, I can set the priority for this one. So for example, I say I want to set this higher priority, highest priority for this task, and then another one with lower priority. Then you can run. We had a GCD to handle the task. The NS operation and NS operation queue. This one is just the high level wrapper of the GCD. So this is a little bit low level, and this one is just the high level API. So we'll talk about this one later. So first one, the GCD. So normally when you do the code, so if you put this code and then another code, so it will run one by one, right? This one, this one, this one. But what if like you want to run the code concurrently, two block of code run at the same time, or you want to put it there, so you don't know which one will finish first. You just want, hey, just run whoever finish first, just finish it. Then you can put that one into the GCD. And this is an important thing, so you need to remind this one all the time. So the main thread, just everything you want to update the UI, that one should be in the main thread. For example, if you want to update the image, you have block of code to download the image, and you want to set that image into the UI image view. So that code must be in the main thread. So you don't want to put it somewhere in the background, because that's in the background will be lower priority. It will the OS will have the higher priority for because that's one user interacting in the main thread for the main thread for UI. So you will prioritize to run the code in that block first. So if we put that one, the image, you can download the image in background, but then when you want to update the image, you need to put the image into the main thread. We had this one, dispatch queue and main async. So later we go to the code and we see how we use that one. So this is an example. Let's go back. We go to this one. We want to do some fun thing here. Okay, so here I have don't need to care about the UI for now. I just have a view controller, and inside this view controller, so let's try with the symbol queue. So this is how you create a queue. So take a look on. Well, everyone can see. Let me try to make it bigger. Where is it? Presenting, font and color, and then presentation. Okay, so let me make it bigger so everyone can see. Clear this one for now. So let's try with something simple. First, we try to create a queue. So again, this one, the dispatch queue is the class we want to use. So first, we want to create just a symbol queue, and then create this one. You can set it a name for this queue. So whatever you want to put there. So just set a name. And then when we have a queue, okay, so if we want the code to run asynchronously, right, then you can use async, but let's try with something simple first, synchronous. So we want the code to run synchronously, meaning it will run one by one. After you finish this one, it run another one. So in this case, I use the synchronous one, and then we have a code here, right? So what we want to run here, so we have a queue and synchronize, and I just print out like 10 times. So in this case, I just put like just different color. Later it print it here. You see different color. It's easier to read, for you to recognize which thread is running. Right. So I have a synchronized queue here, and then this one, if I don't say anything, this one will be in the main thread. Okay, so this block will be in the main thread, and this block I create a queue for it, and I put this one, and I say, hey, please execute this one synchronously. Okay, so what do we expect here? Try to guess what will be the result. I remove this one. Let's run a synchronized queue first. Can you guess? 1 to 10, but the red one first or the green one first? The green one first. Okay. Anyone have any objection? Do you have any different idea? Which one will be run first? Red and green. So 10 red and then followed by 10 green. Okay, let's run and see what happens. Yeah, synchronous. Okay, so look at this. We have 10 red and then followed by 10 green. So why? So when we create a queue here and we say, hey, this queue we need to run the code synchronously. When I say synchronously, it will run just right away, and whatever be after that one, you need to wait for this. I don't care if you are in main thread or wherever. I run synchronously, meaning I need to run first. Whatever be after me, you need to wait for me. Right. So this one you see, even we are in the main thread. Right. Later I will tell you. So when we create a queue like this one, so what is the priority? But for now, just create something. This could be default, but default is what level of priority. So for now, just keep that in mind. We go to that later. So you see a synchronized queue. So it will execute that one first, and then even this one in the main block, it need to wait, right? So let's move to this one. We run an asynchronous queue. So again, we create a queue, we label it. So the label is, it doesn't matter, whatever you want to name it, never mind. And now I say, hey, I want to run this one asynchronously. Again, I also have this one to run to print in the main thread, right? And then let's see what happened. Let me comment this out and comment this. Okay, so we have asynchronous queue here. We still print 1 to 10, and this one in the main thread, right? What do you expect? Let me hide this one. What do you expect? Tang? Just guess which one will go first. So it's not in sequence. So alternative, some yellow and some blue, right? Okay, let's see. Nothing. Oh, it's not nothing. Okay. Okay, you see here. So yellow, blue, yellow, blue, yellow, blue. Right. It's quite even. You see the even distribution, right? Alternately, one yellow, one blue, one yellow, one blue. Is this what you expected? Okay, you're right. That's this one. So now the one in the main thread, it will not wait for this one, right? So it now is running on two different threads. At least the iPhone has 2 cores, and then it can run on 2 different threads. Then is it like, what if I made it a little bit longer and see if it's still the same, or because this one is too short and it run at the same time. Okay. Okay. Ooh, wow. It's no longer one blue, one yellow, one blue, one yellow. At least I know that, hey, the yellow one finished first, right? See, the yellow one is finished at around the blue one should finish 80%, but the yellow one will complete it. Right. Why? Any idea? Javen? Oh, why the yellow one finished first? Hmm? Yes, so it will be on the main thread. So again, the main thread will be the highest priority. The main thread is this one for you update the UI. So again, it will be highest priority. So if you create a bunch of things, it will be strong way finish first. Before you just create, you run from 1 to 10, but too short. So even something finished before other things is very hard to recognize that one. But you create some tasks running very long, and then you easily can detect that, right? So you see here, so at first it's still like run this concurrently, but then at some moment, like here, it start to prioritize. Hey, this one I'm higher priority, and it just run me first, right? at some moment it still has some yellow, some blue, like insert in the middle of the yellow one, but you still have a higher priority for the yellow one, so it finished first. Right, so it doesn't matter. So in this one, it doesn't matter where I put this code, right? If I put it above the queue or after the queue, same thing. It doesn't matter, right? In this case, I purposely put it after the queue to prove for you that hey, this one is even the queue. The queue is the code in front before this block, but it still finish faster, finish later. Okay, so move it back. Want it move down. Okay. Okay, so that's about the ASIC queue. What next? Okay, so now we talk about the priority. So let's set on this one. So let's queue this part queue, and then if you look at this one, it had two initializers. Right, the first one just simply label. So when it just say label, so why the priority? It's default, but when default it will be at equal level. And then the second initializer, we had the label, we had the QoS. So QoS is quality of service. So that's how it defines the priority. So let's go back to this one. We have the QoS here. Take a look at this one first. Okay, so this QoS is the quality of service, and then it indicates the priority of the task. Right. And we have the documentation from Apple here, and then we have six level of the priority. So the highest one, so from the top to bottom is from the highest to the lowest one. So the first one on the user interactive. So this one is on the main UI. So interactive means something you can interact with your screen, your device. And that's one is highest one. The second one is user initiated, and then the default. So here the default one. If you don't declare anything, then it will be default. So it will be somewhere here. And then later you have the utility, and then the background, and then unspecified. So if you set the task priority based on this one, so it will be complete earlier or later, depend on this one. So here the documentation from Apple, if you want to take a look, you can click on this one. It have the full explanation on which are on every priority here. Okay, let's go back to our code, and then okay, we have this one. We have this. If you look at this one, the second ones have a lot of parameter here. But for now, if you don't want to use anything, just remove that one. Okay, so now you just say, hey, I just want to set the priority for the block. So I need to just stop here. The rest I just remove. So I remove this top line. Okay, so I did this one. So now I have two queues. The first one I set the priority user initiated. So if you go back to this one, you see this one is just right after the user interactive, meaning it had a second highest priority. Okay, and then on the Q2 is the background, so almost the last one. It's just higher than the unspecified one. So we have one very fast and then one very low priority. And then now we print this one. Again, we print 100 red one and another 100 green one. So what do you expect on this one? This one run first. Easy answer, right? So you know the red one is have higher priority than the green one. But most of the time we run on the simulator. Now let's try to run on the phone, see if it's still true. My phone only have 2 threads. It's not. I don't know the simulator how many. Okay. I already tested that at the same time I can recording the video and also show the my phone screen on good time. So good one. New movie recording. You will record my face. Okay, switch to my phone. What happened? Oh, grass.